Today we're going to look at a couple of examples of inverse trig functions, and in particular, I'm going to talk a little bit about triangle trig as opposed to trig on the unit circle as a precursor. So suppose we have a right triangle. There's my angle theta. This is 90 degrees. I call this side opposite, this side adjacent, get it? And this is the hypotenuse. All right, I claim that whenever you have a right triangle like that, the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over the hypotenuse, and the tangent of theta is opposite over adjacent. And those of you who have done a little trig in the past probably recognize that. In fact, oftentimes triangle trig is all that's taught. And there's this little mnemonic device down here. Sine is opposite over hypotenuse, so SOH, get it? Cosine is adjacent over hypotenuse, so CAH. Tangent is opposite over adjacent, so TOA. So a lot of people have been taught to remember that by the Indian phrase SOHCAHTOA. Indian phrase in quotes, right? SOHCAHTOA. All right? So now I want to talk about why that's true. The bottom line is, the way I introduce sine theta and cosine theta is they're the coordinates of where the terminal side intersects the unit circle of radius 1. So let me show how this fits this. Okay, so let's take our triangle here. Here it is right here. Adjacent, that's along the x-axis, opposite, parallel to the y-axis, and there's the hypotenuse, and there is my angle theta. All right? So we all know that with a triangle set like that, cosine of theta and sine of theta are defined by exactly these points. But look at these two triangles. They are similar. They're similar. The hypotenuse of the larger one is big H. The hypotenuse of the smaller one is 1 because it's on the unit circle. So now I have to figure out my scaling factor like we did early on. What do I have to multiply H by to get 1? And of course the answer is 1 over H, because that's what I multiply the other two sides by to get these coordinates. And those coordinates are important because they'll give me the value of sine and cosine. All right, so the other sides in my smaller triangle are what? O divided by H and A divided by H. But if you look at that, this is A divided by H. That corresponds to the x coordinate of this point. Hence, cosine theta is A divided by H. Sine of theta, okay, the y coordinate of this point, O divided by H, and there you have it. Cosine theta is A divided by H, sine theta is O divided by H, and of course tangent theta, which is sine theta over cosine theta, you can easily see to be O divided by A. All right? Now let's look and see how we can apply that little thing to this problem. So what's the cosine of the arctangent of minus 1/2? Okay, so what's the arctangent of minus 1/2? It's an angle whose tangent is minus 1/2. And that angle, arctan of minus 1/2, has to be between minus pi halves and pi halves. Well, now let's think. Right? The tangent is minus 1/2. The arctan kicks out values between minus pi halves and pi halves. Those are exactly values where the cosine is what? Positive. Yes, positive. So that's how I know that my final answer is going to be positive, right? That's the way I figure out if it's going to be plus or minus. And then after that, I really ignore this minus sign here because I've already figured it out, right? So now what do? Well, I draw a triangle whose tangent is 1/2, right? Not minus 1/2 anymore because side lengths of triangles are never negative. Well, to have tangent 1/2, here's my angle, the arctan of a half, if you will. Tangent is what? Opposite over adjacent. So I put a 1 here and I put a 2 there. But that's a right triangle, which allows me to figure out what this value is by the Pythagorean theorem, and I get the square root of 5. After that, I look at this triangle and I ask, what is the cosine then of that angle? Well, cosine is what? Adjacent to over hypotenuse square root of 5. So the cosine of the arctangent of minus 1/2 is 2 over the square root of 5. Now, I've ignored this minus sign, but I've already argued that my answer has to be positive because of where this comes. Therefore, here we go. Cosine of the arctan of minus 1/2 is 2 over the square root of 5. And that's the way you figure it out, right? Let's look at the final example. Suppose I want the tangent of the arc sine of minus 3 over the square root of 13. All right, well, my angle, since it's the arc sine, is going to have to lie between where and where? Minus pi halves and pi halves again. But between minus pi halves and pi halves, the cosine is automatically positive. So here it is, right? The cosine is positive. The sine, which is minus 3 over the square root of 13, is negative. So I have a negative sine over a positive cosine for tangent. That tells me what? Tangent has to be negative, right? So I figure out what my signature is of tangent, that is it plus or minus, before I even start the problem. And it's because of where this angle is, right? Now, once I know that my tangent is going to have to be negative, then I'm free to draw my triangle and ignore this minus sign, right? So, what do I want? I want a triangle whose sine is 3 over the square root of 13. Okay, now what is sine? Sine in this right triangle is what? Opposite 3 over hypotenuse square root of 13. All right, so here we have it. There's 3. Here's the square root of 13. That allows me to compute this, which, by the way, I've realized that I've done incorrectly. So let's change it. What is it by the Pythagorean theorem? It should be not the square root of 2, but rather 2, right? Because what? 3 squared add 2 squared should be 14. Alrighty, so that means by the Pythagorean theorem it is 2. And now we're going to change things down through here. All right, so now what's the tangent of this triangle? The tangent is opposite 3 over adjacent 2. So I get what? 3 divided by 2. And then remember way back up here, I argued that the tangent must be negative. So drawing a triangle ignores the signature, whether or not it's plus or minus. That's figured out ahead of time. I already figured out tangent has to be negative. So tangent is minus 3 over 2. And there you have it. All right? So that's a couple of examples there that you'll find similar to things in your homework, as well as the argument of how triangle trig relates to trig on the unit circle. Bye.